Hi, this is the LeetCode 1909. Remove one element and make array strictly increasing. So we're given an array of zero-indexed array nums. Return true if can be strictly increasing after removing exactly one element, or false otherwise. If array is strictly increasing, return true. The array nums is strictly increasing if yep, and inside index. So this is what we have to we'll have to check. And this is example. We have array and it's increasing, but one element is outstanding and it can be removed and array will be increasing. Correct. By removing 10, index 2. Yep, so we return true. This we can remove 1, right? And it's not be increasing, so we return false. Yeah. Constraint 1000. Very good. So first, yes, so this is what we have to do. We have to enumerate through arrays and check this condition for array. If we have opposite condition, then we have, so I will do this. First, enumerate array from 1 to n in 1 to n. Then first we check if this condition is not is true, meaning then we possibly found problem with array. Then in this case we will have to check and I would also define attempts, which is amount of attempts we can, amount of elements we can delete. It could be 1, it could be 2. So check if we have if attempt is more than 0. Then another check. Then we check if we can delete I, or can delete I plus 1. So, and then if we can, and we can delete. And if we can, we reduce amount of attempts. Otherwise, we just return false. And this is in this enumeration. It's a body of enumeration. Let's do this. And at the end, we just return true. So let's have this. Let's have a dry run for this array. Right? We have here. We have we start from 1. Have I here. And we check if I minus 1 is more than I. No. Then we continue. We check if I minus 1, if 2 more than 10. No. And here we are checking if 5 I minus 1, which is 10, more than I, which is 5. This is true. Now, if we can delete I, we can check it by, can we I minus 2, right? This one is less than I. Meaning we can delete I minus 1. Yeah, so this is incorrect. So we can delete I minus 1 in this case, right? And this are our condition will be. So here, like this. Can we delete I minus 1? This is our condition. So I minus 2 is less than I. Or also, we can have a different situation. Let's have a situation like this. Right? And just swap it like this. And we have I pointing at 10. And in this case, no, this is correct. Okay, yeah. So we have to check this condition, and we don't have example how to. Yeah, let's run through this example, right? So first it's increasing, now it's decreasing, right? We have I here. And I minus here. So for this, we have to check, can we delete I? Because this seems correct, but can we delete I? And to check this, we have to check if I minus 1, right? If this is less than this. Minus I plus 1. So this is this part condition. Can we delete I? All right. Okay, so it should work then. In this case, it will be false, but in this case, we can check both conditions and it should work. So I'll go ahead and code it really quick. So first we have to transform this into source code. Okay, yeah, very good. So first we put here, then we do for E in, we have to define the len, which is length of nums. right? Here we go in range from 1 to n. I would put, oh, okay, so look at this. So we have a 1, 1, 1. So this condition must be like this. So then we check if attempts more than 0, and we have to copy both of these conditions. But the thing is that we have to check also when we're doing this, we have to check, and this, we have to check for boundaries, right? This must be not less than, and like this, our I minus 2 is okay, less than 0, or this will be condition, because we have to check for boundaries. If boundaries are, for example, if I cannot check if for beginning of array if there is no element on when I delete one and delete first element and there is no element earlier, I have to, I can, there is nothing I can check of, then meaning it's okay, right? This is why we have to specify or. And the same here, so if I plus 1, if I plus 1 more than length, or it will be pretty big condition. I think let's create this and like this. Let's declare variables. Can delete I or can delete I1, I plus 1, right? Then we do attempt minus 1. Else we return false immediately, and otherwise we return true. Okay, so the only things left to do is to define CDI and CDI1 variables. So let's do this. CDI1 will be so CDI1 will be can delete I1 as 1, and CDI yeah, this will be CDI equal, and we need this nonce nums. I like it because like having variables, it make code more readable than having like everything in one giant if. And it's also good for debugging if I have to debug code and check why it's not working. All right. So let's run this code against first example. So we can skip all the way until I pointing on 5. Then we will identify if we can delete I. we don't have to identify this but we just like, okay, we will calculate it anyway. It's one calculation, excessive calculation, but for code clarity. Okay, I will do simple excessive calculation just to have a code clarity. And here I plus 1 is more than equal to L, no. Then I minus 1, which is 10, less than I plus 1, no. So we cannot delete I. But can we delete I plus I minus 1? And for this I minus 2, which is pointing on 2, right? So this will be I minus 2, is less than I, 5. We can delete, so it will be true. And we go from here into here. And we reduce attempts and return false. Okay, I think that's it. Let's give it a try. Okay, missing, oh yeah, missing semicolon here. And this should be inside. Yep, like this. Okay, and it's not defined. Oh, it's out. Sorry. Okay, now let's submit it. Yep, and we have bit 70%. Yeah, I probably because of excessive calculation. I don't know, should I remove like entire thing here and entire thing here just to speed it up? It's okay. I like it the way it is, but yeah. So let's see other solutions. Oh, it's 2 pointers, yeah. And we just pop remove element. Okay, that's also a good solution, just to remove element if you don't need it, and then sort it. We sort it. Okay. How it could be faster? I mean, this solution. Oh, I forgot to say what is time complexity will be for this solution. Will be ON, right? And space complexity will be O1 because we're not declaring any external structure. We're just going through that. Oh, this one is similar like mine. But they are also using 2 pointers. And they said like removed, yeah, okay. So they don't have attempts, but similar. It's totally like mine.